So another interesting application here. If any of you ride bikes and have a speedometer on your bicycle, they often will calculate your speed and your distance traveled based upon the number of revolutions of your tire. The ones that I have sort of have some magnets that come in contact every time the tire rotates, and yeah, the computer in the speedometer then can count the number of revolutions and can keep track of then your speed and your distance traveled and things like that. And really what the computer is doing is utilizing some of these formulas. So here's an example of how you might go about doing this without the use of the computer. It says a 26-inch diameter bike tire turns at a rate of 280 revolutions per minute. So if it counts 280 revolutions in a single minute, how fast is the bike traveling in miles per hour? Now, of course, when you're actually riding on a bike and using one of these speedometers, it's not waiting a whole minute to count. It's counting them in a shorter interval, like a 5 or 10 second interval, and then multiplying it out and using the revolutions per minute conversion to then calculate these things, okay? So if you knew 280 revolutions per minute, how fast is the bike traveling in miles per hour? And then that would then be the readout on your speedometer. Okay, so here's how we want to think about this. We know revolutions per minute is going to have, it's going to be some sort of relation to omega, right? Omega is an angle. Revolutions are related to angles because each revolution is 2 pi radians. And so we also have a radius here. So really we have everything we need to be able to use our linear speed formula, okay? So what I want to do then is figure out what r and omega are. Well, the radius, first of all, I know the diameter of the bike is 26 inches. So that means the radius is 13 inches. Okay, so that's the first thing. The omega, if you get 280 revolutions per minute, omega then is just a unit conversion from revolutions per minute to radians per minute, okay? So omega, you really want to work with, if you have 280 revolutions per minute, then you want to multiply by, let's see, there's 2 pi radians in 1 revolution. So you do 2 pi radians per 1 revolution. The revolutions cancel and you're left with radians per minute, okay? So that's going to give you your angular speed. Well, 280 times 2 pi, that's 560 pi. So you're looking at 560 pi radians per minute. Okay, so now when I put this all together into my formula, I know that V is R times omega, so it's 13 inches multiplied by, and now I'm going to write this as a fraction with the per as my fraction bar. So I'm really looking at 560 pi radians per 1 minute. Now ultimately I want to convert this into miles per hour. So my inches and minutes need to eventually convert to miles and hours respectively. Okay, inches and minutes. So to convert inches into miles, we have to do a multiple step conversion here. I'm going to convert, first of all, inches into feet. Well, we know there's 1 foot and 12 inches, right? So I'm going to convert by multiplying by 1 foot divided by 12 inches. Again, the inches go on the bottom to cancel out with this inches. And I also know that there are 5,280 feet per mile. Okay, that's a common conversion I want you guys to be familiar with. So we're going to have 1 mile in 5280 feet. Okay, so now we are able to cancel out the inches, cancel out the feet, and we're left with miles. That's good. Now we got to get rid of the minutes. The minutes then are going to be, we're going to convert them into hours, and we know there are 60 minutes in an hour, so we're going to multiply this by 60 minutes per 1 hour, and that will allow us to cancel off our minutes. Okay. Now what's interesting about these unit conversions is that we don't always have to cancel out the radians. The radians end up not really factoring into the units when we're done. So this, as it is, will be converted into miles per hour. We can often ignore the radians in those unit conversions. So when I go ahead and calculate this, trying to see if there's any nice simplifying I could do. I could do this real quick. I could simplify the 12 and the 60. I know 12 goes into 65 times, so I'm going to go ahead and get rid of the 12, call it a 1, get rid of the 60 and call it a 5. That will just make things a little bit easier as I go through this. Okay, so now I'm going to pretty much just type it all in. Everything in a numerator I'm going to multiply, and then I'll divide by the denominator after that. So I'm going to go 13 times 560 pi, and I want to calculate, I want to type all that in, times 5. Okay, so there's my numerators, not focusing right. Focus, there, okay. Hit enter. Okay, and I get approximately that number. I don't know what that is. 114,000 something. Okay. So that's my numerator. Then I'm going to divide that answer. Well, you know what? I only have to divide by one thing. It's a 5280. So you might as well just hit that. Divide by 5280. And I get about, what's that, 21? 21.7-ish. Okay. So let's go ahead and do that. So this is, velocity then is approximately 21.7 miles per hour, which seems reasonable. That's a little fast probably for a bike. Depends on who's riding it and what kind of nice bike they've got. I know when I ride my bike, I average around a 15 to 16 miles per hour if I don't have a headwind. So they're riding pretty fast there, but that's okay. Just whatever this example, whatever the numbers give us, that's what we get. So 21.7 miles per hour is what we have there.